All right, so in this question, we asked to solve for x if x is between 0 degrees and 360 degrees, and you're given the question. It says 2 cos squared x minus sine squared x minus 2 sine x minus 1 is equal to 0. Think about algebraic expressions. Think about factorization and then methods of that. Also another thing is we've got sine, sine, and then cosine. So maybe we can change that up. We know that sine squared cos squared is equal to 1. So cos squared can be replaced with 1 minus sine squared. And I can change that over there. I can now bring the sine squareds into a single term and then get a trinomial which I can hopefully factorize. So it'll be 2 minus 2 sine squared x minus sine squared x minus 2 sine x minus 1 equals 0. Those two will become negative 3 sine squared x, and then negative 2 sine x remains, and the 2 will combine with the negative 1 to become positive 1 equals 0. Let's change all the signs the other way around by multiplying by negative, and it'll be 2 sine x minus 1 equals 0. Can I factorize this on a normal day? Let's think about it. Let's suppose I got 3k squared plus 2k minus 1 equals 0. And I want to factorize this. I could put 3k and k over there. I could put 1 and 1. And I've got a positive 3 and negative 1. So yeah, that looks like the factored form of that. That's going to be 3 sine x minus 1 and sine x plus 1 is equal to 0. In which case I will have two possible solutions here. I will have sine x equal to a third, and I will have sine x equal to negative 1. And then taking that now into the general solution part, sine x is equal to a third, or all possible solutions, and sine x is equal to negative 1. Let's just make sure I got that right. Is it negative 1 or positive 1? Yep, negative 1 and positive 1 over 3. Let's get the first value of x. Yeah. So we're going to go shift sign of a third, and it'll come to 19.5 degrees. And I'm going to move this one over, shift sign of negative 1. I probably know that, yeah. So it's going to be negative 90. The second solution would be taking 180 minus that. So I'll just write it out anyway. 0.5 comes to 160.5. And the second solution here would be 180 minus, that'll be 270 degrees, because minus minus is plus. So it'll be 270. And going back to the restriction that we have to provide between 0 and 360, so far that's allowed, and that's allowed as well. Do we have any other possible solutions that we can possibly think about? Maybe I got 19.5. If I do a quick sketch, 160 looks like it's over there, 0.5, and it must be between 0 degrees and 360 degrees. Sine x is also equal to negative 1, right? So negative 1, remember, was here. So we know that's going to be 270 degrees. So then we can add 360 degrees here. That's how we actually get to that. So let me double check that quickly. Oh, this was, what's this, 180 minus 90? Yeah, so that's going to be right. So then the next possible solution here would be that one over there. And I think that is the 270 degrees. So then what would this be over here? So 360 minus 90 goes to 270. Yeah. Wait, 1 second as well. And why? Well, if I did that, what am I actually implying? I'm implying that there's two possible solutions, but why not? Because if we know the sine graph well enough, we know that that doesn't exist, because that's where negative 1 is. So that, which means that that's going to be 270, which means there is no other solution. because there's only a single point at -1. But yeah, you might think that because it should be like that, but we must remember that 90, 270, 180, and 360 are going to be like physical actual points, and it's the only time you can get a single point repeating itself every 360 degrees. It's at the maximum minimum point. Okay, and that would